This year, a team consisting of Jackson Nagel, Jordan Baker, Amanda Brawthen, Emily Sjelin, and Adam Wnuk worked with the Society of Automotive Engineers electric vehicle team to design and build the accumulator for the electric vehicle. Throughout this project, our group was mentored by Dr. Kallmeyer. We would first like to thank all of the sponsors shown on this screen for contributing to our project. An accumulator is an energy storage device that powers an electric vehicle. Prior to our team, NDSU's SAE EV team had no accumulator. To solve this issue, our team designed and built the accumulator shown on the screen. While designing the accumulator, we had to reference the SAE rulebook, which outlined all the specifications and constraints of this project.
Before assembly of the accumulator, a lot of prep work had to be done, which largely consisted of deburring the copper bus bars and voltage testing 480 18650 battery cells. Fuse wire testing also had to be done to ensure the correct fuse wire was being used for this project. There were 20 amps of current run through different sized wires until the fuse blew, as shown in this clip.
After the correct wire gauge was determined, spot welding began for the whole accumulator. 720 fuse wires welded to nickel strips are needed to connect both the positive and negative battery terminals. Here we have the polycarbonate segment sheets. They need to be fabricated precisely in order to fit all the lithium-ion batteries and hardware in correctly. Here we have the clips showing the final product of one of the 12 polycarbonate sheets used to create the accumulator segments.
To assemble a segment for the accumulator, the copper bus bars are first screwed into the polycarbonate sheets, then the 18650 battery cells are placed with the fuse wires underneath them, and the second polycarbonate sheet is screwed on top. Lastly, the maintenance plugs are screwed into place with a bent copper bus bar underneath. The first step in connecting the segments was cutting the 2.0 gauge battery cable. The battery cable got crimped into maintenance plugs, which are used to connect the segments. Both the cutting and crimping was done at John Deere, as SAE did not have the tools to do this on our own. Shown here is the final step of using the maintenance plugs to connect each segment.
Due to the large scope of the initial project proposal, the end product of this project will not yet be fully functional. The next step with this project are micro-TIG welding the fuse wires to the copper bus bars, completing the testing, applying epoxy to permanently set all the batteries, and running all current sensors to the correct spots. Increasing the modularity of the accumulator would be the biggest improvement for this project. This would be done by breaking the segments down into packs and adding connections to the packs to put them in series and parallel until the desired voltage and amperage is achieved. Implementing a mounting system to set the accumulator in the vehicle frame is also a crucial next step.
Lastly, our team would like to extend special thanks to John Deere, our mentor Dr. Kallmeyer, our class professor Dr. Ollie Meary, and the NDSU engineering staff, specifically Dr. Omid Beek and Rob Seiler.